And in this episode, we are going to go through a series of videos on how to add CI/CD for containerized applications. So, the services that we are going to use for this series are AWS ECS or Elastic Container Service, which use AWS Fargate. And then we are going to use AWS ECR or Elastic Container Registry to have our container images. And then we are going to use AWS CodePipeline to automate this whole process. So I told you it's going to be 4 parts. In the first part, we are going to look at our containerized application and run it locally. And then we will create the resources on AWS like ECR, and we'll push that image to the remote repository. In the second part, we need to create the network that is required to run our application. So the network, as in like we need to have our load balancers run on a public subnets, so that can be accessible from internet, from anywhere. But the containers that is running inside our ECS cluster should be in a private network which cannot be accessed outside other than through the load balancer. So we need to configure this network, so that will be the main focus on the part 2. In part 3, we will connect all our services and test our application if it all works fine. And if that all works fine, in the last part, the part 4, we will automate everything so that whenever we push a code to our GitHub, it will trigger the code pipeline, and the code pipeline is going to build the container image on ECR. Then it will trigger the ECS to deploy a new container, and our application will be updated without we having to intervene. So that's the plan for this series, and I hope you guys enjoy it, and I'll see you in part 1.
Okay, now this is our GitHub repository, and I will clone this repository by clicking here and copy the URL. Now get back to my terminal and let's create a new folder in desktop. I will call it hello, and I will cd into hello folder, and I will open it in Visual Studio Code. Now I will open up an integrated terminal right here. I will type git clone and the repository URL, and let's clone the content into this folder. Now let's explore the files. I will go into this folder. So there are a couple of files. One is app.js. Now this is our entire container code. So this is nothing but a simple Express application. And this Express application, it has 2 routes. This route is the main route or the default route, which sends hello world to the client. And there's another route. I have named it as /health. Now this we will use it as the health check endpoint for our load balancer. So it's nothing but returning the status code 200 with healthy text. And then we have app.listen. So our Express application is listening on port 3000. So we have opened up the port 3000 for this application. Now if we run this locally, I will just clear the screen. I will go into CI/CD container folder and ls. So these are the files. So I will run node app.js. So in order to run it locally, so we have to install Express. So in order to do that, we have to run npm install. The dependencies are listed in here, package.json file. So it has installed Express. Now let's again run node app.js. So now app is listening on 3000, and open up a new tab and type localhost 3000, and you should see the hello world. And if I go to my health check endpoint, that is /health, it should just give me healthy message. And if I inspect it in network tab and do another refresh here, you should also see the health check status is 200. Okay, now this is the application that we are going to Dockerize. So I will stop the server, and now you can see the Docker file along with the app.js file. So this is the Docker file. So in this Docker file, we have several instructions. First, we will use the Alpine Docker image as our base image. So this is one of the very lightest image that we can run Node.js, or that we can install rather Node.js and npm. So that is exactly what we are doing at the second line. So I am adding Node.js and npm, and I'm installing it using APK package manager. And after Node.js and npm is installed, I will create a new directory /app and I will set it as my work directory. So all other commands beneath here will run inside this directory. So what I'm first going to do is I'm going to copy the package.json file. So this file into this /app folder. So that's what I'm going to do here. Copy package.json into the folder I created here. And then I'm going to run npm install. So at that point, I haven't yet copied all my source code. That means app.js and this gitignore file or any other file that may contain in your application into this app folder because I just want to use the Docker caching benefits. So I run npm install to get the Express package installed. And after that, I will copy the rest of the code here into my app folder. So the rest of the code will get copied into app folder. So then I will expose 3000 because my app is running on port 3000. And then I have a cmd command. So this get run when somebody issue a docker run command on the image that is built from this Docker file. So as the run command, I will run npm start, which will run my application. So let's try this in local machine. So I'll open up the terminal, clear the screen, and let's see which folder I'm in. Okay, I have the Docker file and everything here. And let's first build this file. So I will type docker build and let's tag this image -t YouTube. I will just say local and this is the latest version. And then I will add period. So the period denotes the path of the Docker file. So which is right in this folder. So that's why this period here. And then I will hit enter. So it's going to build my image and it is successfully built. You can see this, it ran through the steps. And now if I just do Docker images, I should see my YouTube local repository, which is this one. Okay, now let's spin up a container using this Docker image. So I will just copy this image ID and then I will clear the screen and let's run the command docker run in interactive mode -it and I will do a port mapping. Now the Express application that will be running inside this container will run on port 3000. So let's do a port mapping to host to the container. So I'll use port 80. Okay, let's use just 80 through to port 3000 inside the container, and then I will just paste the container ID which I just copied and hit enter. Okay, the application is running. So now instead of localhost 3000, I can just type localhost and hit enter, and there you go. Hello world is shown. Now it is running inside the container. Now in order to run it locally, you have to install Docker in your machine and make sure Docker is running in your machine. It could be Mac OS, it could be Windows or Linux. You can simply install Docker for that. So now let's push this image to a remote repository. Now for remote repository, you can either use Docker Hub or AWS ECR, Elastic Container Registry. We are going to use ECR or Elastic Container Registry that is managed by AWS. So I will go to AWS and I will search for ECR. I will click create repository. So let's create a remote repository. Type YouTube and create the repository. So you have your Docker repository here. Now this is the URI of my repository. Now in order to push an image to this repository, we have to use this URI. So if I go into this repository at the moment, I don't have any images. So let's push that local image up to this ECR. We'll come back to my terminal. Now first we have to log into AWS in order to push images to ECR. Now open up this ECR command.txt file. So we can use this command here, AWS ECR get login and then the region. Now before running this command, you have to install AWS CLI in your local machine. So if you haven't installed, you can go to a browser and simply type install AWS CLI. That will take you to the first main URL here. Click on that and here you can see how to install AWS CLI on different operating systems for Windows, Mac OS or Linux. So you can follow the instruction and get it installed. In Windows, it's just a matter of installing an MSI. And once you have set up, go back to your CLI and then execute this command. I copy this and I paste it here and hit enter. Now we are logged in successfully. We have used US East 1 region because our ECR repository is in this region. Okay, now let's build a new image. I will use this command docker build -t. Earlier we built for local, YouTube local. Now let's call it just YouTube. And the context is dot, so it can find the Docker file in the same folder. And I will hit enter. So it's going to build that image successfully. And once it is built, I can tag that image. So in order to do that, I will type docker tag. Then here I have to type the image name. So the image name I used is YouTube latest. So I will paste it here. And then you have to point it to the remote repository. So in order to find the ECR URL, you can simply go to your repository here and just click on the copy button. It will copy this URL and come back to your terminal and paste that in, and I will tag it latest at the end. So it will mark as the latest one, and I will hit enter. So it is now properly tagged. Now we can easily push it to ECR by using docker push. I'll type docker push, then I have to again paste the ECR URL which I just copied. I will paste it here, and then I will add the tag name again, :latest, and I will hit enter. So that's going to push my local image up to my remote repository in ECR. Okay, now it is successful. I will go back to my repository and I will click on the YouTube. So now I can see the latest image tag, and this is my image URI. So it is successfully pushed onto my ECR. Now we completed the part 1. And now let's use AWS ECS or Elastic Container Service, and we will use AWS Fargate type to run our container without we having to manage any resources. But first, we need to set up our network properly, because we don't want our containers to run in a publicly accessible network. We always want our load balancer to be accessible over internet, but our tasks or the containers should be in a private network. So in order to achieve our network requirements, let's create a separate VPC or virtual private cloud for our application. So I will click on services here. I will type VPC. So now we can set up our custom VPC or the custom network that suits our application. So I will just click VPC here, and I have a default VPC, but we're not going to use the default VPC. Instead, I'm going to create a new VPC. I will call this as, let's say, my VPC. And for the CIDR range, we'll use 10.0.0/16 CIDR range, and I'll hit create. So it's created. I will close this down. So this is the VPC I just created. Now inside this VPC, let's subdivide this network into 4 subnetworks. And we'll designate 2 of those subnets as public subnets where our load balancer will run, and 2 of those subnets as private subnets where our tasks will be run. So I will go to subnet sections here. I will click create subnet. First I will type my VPC public 1. So this is my first public subnet. Let's pick the VPC, my VPC. And I will pick availability zone US East 1A for that. And let's divide our main/16 CIDR into 4 sections. And for this one, I will type 10.0.1.0/24. This is a /24 CIDR, and I will click create. So my first subnet is created. Filter it by the VPC so we can properly see this. Okay, VPC is still not shown. I will refresh this, then it should show. Here you go, my VPC. And this is my first subnet I just created. So that's a public subnet with 10.0.1.0/24. Okay, now let's create the second public subnet. I will click create subnet, my VPC public 2, my VPC, and the availability zone earlier it was East 1A. I will choose East 1B, and let's pick the CIDR 0.2.0/24. Make sure these subnet CIDRs are distinct. Now they are not overlapping. So 1 and 2 is created. Then I will create my private subnet that would be named as my VPC private 1 my VPC availability zone. I will just pick the east one again, 0 dot, this time 3.0/24, and last private VPC, or the private subnet rather, private 2 my VPC, this time UST east 1, and let's name the site as 10.0.3, I think it's 4.0/24. Well, you can divide your subnet as required. So this is how I chose. In order to make my public subnet actually public, I have to attach an internet gateway. So I will create an internet gateway here. Click internet gateway. I will type my VPC IGW for internet gateway. Create it. So it's created now. So it's at the moment it's detached. So I will click actions and attach to VPC, and then pick the VPC, my VPC here, and click attach. So it is now attached to my VPC. Now I will create two route tables and attach the internet gateway I just created to one route table, and then attach that route table to my public subnet. So I will click create route table here, name tab, I will type my VPC public route table, RT for short, and the VPC is this, and I will click create. So route table is created. So this is the one it just created, and now I will click routes under here, and at the moment it has only the local route, but we want to add the route that points to internet gateway as well. So I will use this any path pattern, that means any route other than this local routes, it should go to my internet gateway. Then it will suggest the internet gateway here, pick that one and save routes. So route is successfully created. You see now I have two routes. So any route outside my network side will be directed to the internet gateway. That is fine. So I will create my second route table. Let's type my VPC. This time it is the private route table. I will just pick the same VPC and create it. So it's created. Now this route table I don't need an internet gateway attached. Now what I will do is I will attach this private route table to my two private subnets. So I'll click subnet association and edit subnet association. So I will select private 1 and private 2 and hit save. So those two subnets will be associated with my private route table. Then I will select public route table with the internet gateway attached, this, and I will go to subnet association, click edit association, and this time I'm going to select the public subnets, public 1 and public 2, and save it. Okay, now we have done with our network creation. Just to summarize, so I have created a VPC, my VPC with 10.0.0/16 slider, and I divided this entire slider block or the net IP address ranges into 4 IP address ranges. So those are my subnets right here. If I filter it by my VPC, I have two private subnets which has the private route table attached, and it has only the local route which route within the VPC, but I have two public route tables where it reference the public route table. So my public route table has an additional route for any other IP addresses outside my VPC to route to the internet gateway. So any resource I will add into this public subnet will be accessible from internet. So in this series we are going to spin up our load balancer inside our public subnet, so that can be accessible from anywhere in the internet, and our containers, those container tasks, we will be spinning up inside our private network, and we'll set up the configuration that only our load balancer can access those containers inside our private network, but not anybody outside. And in this part 3, we are going to create our ECS cluster and create task definitions using our Docker container image. So I will click services here, and I will search for ECS or Elastic Container Service. So I have a couple of clusters at the moment, but I'll create a new cluster. I will click Create Cluster, and then I have few choices. Networking only, powered by AWS Fargate. So this is the one that we want to use because we don't want to manage our cluster compute resources like EC2 instances by ourselves. So we'll let AWS to manage it for us. So that's why we use AWS Fargate. So I will click next step, give it a name. I will just type my cluster and create a VPC. So here we have to create a VPC for this cluster. I will just accept the default CIDR blocks and I will click enable container insight and click create. And now I will click view cluster. Okay, I can see I am in my cluster. So now that I have created my cluster, we can create a task definition and then create a service out of this task definition and have our Docker containers run inside this cluster. So the first step is to create a task definition. Now this task definition is just like a Docker container. So if you click on task definition here, I can click create task definition, click Fargate launch type here and next, and then give it a name. I will type hello world. Now I can assign a task role. So this is basically if I want to access AWS services from within my application that is running inside the container, then I have to assign a IAM role with the permissions. But the application running inside this container is only returning hello world to the request, so we don't need to specify a task role here. And the network mode AWS VPC is by default selected. And then I have to create a task execution IAM role. So you can click create a new role here. Then I have to specify some configuration related to the task or the container. So how much memory do I need to allocate to my container or the task? Let's say 0.5 GB and vCPU, okay, 0.5. Okay, I will pick 1 GB for task memory and vCPU 0.5. And then we have to add container definition. So click add container. You can give it a name. I will tell hello world. And then I have to specify where this Docker image resides. So basically repository URL / image :tag. So I will open up a new tab and go to ECR or Elastic Container Registry. And this is my container repository URL. And I will click on to that. And this is my image URI. I will just click here so it will copy the URL. I will go back to the ECS and paste it here. So it's referencing my YouTube image, the latest tag version. And I can specify memory limits and so on, but I'm not going to do that. But here in the container port mapping, so I will say, okay, my container is exposing port 3000. So that I want to map to any port from the host. So in this case, we don't have any access to host because that is managed by AWS in Fargate. So we just have to specify the container port here. And the rest, just leave it as it is. For example, you can add any environment variables, so on. But let's not focus on that now. I will click just add here. And then let's click create. So hello world is successfully created. Let's view the task definition. And there it is. So now I go back to the clusters here. And then you can see my cluster, the one I created here. I will click onto that. So now it's time to create a service. So I will click create and the launch type again I will pick Fargate. And the task definition, hello world, the revision, let's say the latest one. The revision number may differ in your case. And the platform, keep it latest. Cluster, my cluster, service name, let's call it hello world service. Now we have to specify number of tasks. So how many tasks should this service manage? So let's say I want to manage 2 tasks. So this service will manage 2 tasks. If one fails, it will remove it and spin up a new task from that task definition, this one. And minimum healthy percentage and these things will keep as defaults. And then the deployment section. The type of deployment that we are going to use is rolling update. So select on that and I will click next step, and here I have to pick the VPC. This is the time we are configuring the network for our tasks or the containers. So here I have to select my VPC. So in order to get the VPC ID, I will go to VPC dashboard here, and let's see, this is our VPC. If I go to your VPCs here, my VPC starts with 00108. So let's search for that. And there it is, 00108. Okay. And now I have to pick the subnet. Remember, our task will be spinned up in the private network or private subnet. I will pick those private subnet 1 and subnet 2, and then I have to specify the security group. Here I can just edit the security group, and can you see at the moment the security group accepts HTTP from anywhere. But we want only our load balancer to access these tasks. So how can we do that? We can actually use the load balancer security group ID. But so far we haven't created our load balancer. So we can edit this security group later. Hello W2131. For now, let's keep the source anywhere. And I will click save. Now, in order to create the load balancer that balance our request across the tasks, I will select application load balancer under load balancing and health check grace period. So this is basically how much time the ECS service scheduler should ignore elastic load balancer unhealthy targets checks, because it takes some time to spin up a task from the task definition. So we'll just say stay about 30 seconds. So I will pick application load balancer. Out of 3 load balancers, I can either pick network or application or classic. Classic will not work in this case because this is AWS Fargate. So it has to be application load balancer or network load balancer. This load balancer supports balancing traffic out to different resources on IP addresses. In this case, tasks on specific IP addresses within our VPCs. So I will pick application load balancer here. And balancer name, well, I don't actually have a load balancer at this moment. So there's this message, no load balancer is found. So a link is given to me. So I will just click on that in a separate tab, and then we'll actually create a load balancer. So here I will pick application load balancer and give it a load balancer name, my ALB for application load balancer. And the listener port HTTP 80 is already created for me. So load balancer will listen on HTTP on port 80. And now I have to pick the VPC that this load balancer should run. So my VPC, and what are the availability zones that it should create load balancer nodes. So I will pick both US East 1A and US East 1B. And let's pick the subnet. Make sure you pick public subnet 1 and here public subnet 2, because we want everybody on internet to access our load balancer on port 80. It has to be publicly accessible. Only our tasks are in the private subnet, which can only be accessed by this load balancer. So then I will click configure security group and click again configure security group. I will check create a new security group. Let's say my ALB SG for my elastic load balancer security group, and I will add HTTP on port 80 from any resource. So 0.0.0/0 represent any IP addresses from within internet. So I have added this inbound rule so anybody can access my load balancer. And then I will just click configure routing, and this is the place where we have to create our target group. Now any request that load balancer will receive will be sent out to a target group. So we don't actually have any target group set up. I will click at new target group, give it a name, my ALB target group, my ALB TG. And here this is very important, we have to select IP, because the service that we created in ECS will create tasks from within our VPC. So it will use specific IP addresses within our private subnet that we define for tasks, and it will allocate those IP addresses to those particular tasks or containers. So our load balancer should be able to spray traffic to those IP addresses. Okay, protocol is HTTP and port is 80, and the health endpoint, it is health, if you can remember. So our application, the Express application, has a route called /health. And then I'll click next register task. So I'm not adding any static IP addresses right here because we'll allow our ECS to dynamically add those IP addresses registered in the load balancer, right? So we are not statically type anything here. Let's just click create. So it's going to create my load balancer right there. Okay, I click close here, and this is the ALB that is created. I'll go back to the previous tab I opened here, and I will click refresh button. There we go. It actually selected my ALB, and it has already picked that task definition hello world and the port that we have exposed it 3000. So that is good. Then I will click add to load balancer button. Now I can select 80 port 80 HTTP. So that is the listener port of my load balancer. So load balancer is listening on port 80 and the listener protocol is HTTP. So any traffic that is reached out to my load balancer on port 80, we should direct to my ALB target group. There I create the my ALB. So you can see the target type is automatically detected, and a health check path has already been automatically detected because we have already configured this when creating our ALB. So that seems all fine. And under service discovery, we'll unselect this because we don't have any other microservices to work with this microservice. If there is, then this will be really useful to address microservices separately. So then I will click next step, and auto scaling options I will keep the default and click next step, and finally I will create my service. Now I will view my service. You can click details here, and I can select my cluster again to view my service. I will click my cluster. You can see one service is already there, and this is my hello world service. And as you can see, the desired task count is 2. So this service is managing 2 tasks, but at the moment 0 tasks are running. Now I go to tasks tab just to see how it is going. And as I can see, the status is still pending and the desired state is running. And I will do a couple of refresh, still pending. And after some time, you should see one task disappeared. Well, if you go to stopped section, you will see, tasks are stopping. Now this, 2 tasks has been stopped. Now what is the reason here? My tasks are not running. No, they are not coming into the desired running state. Now this has to do with internet accessibility within my tasks. Now we spin up task in a private subnet which does not have any connectivity to internet. But if we look at our Docker file, and there is this particular line that runs npm install, which pull all the dependencies of my package.json file like Express and then install it. So when my service is spinning up tasks from the task definition, so it's going to run this Docker file. But at this point, it cannot do it because there's no internet accessibility. Hence, the task fails. So that's why our tasks are never coming into running state. So what is the option? We don't want to have our task in a public subnet that everybody can access. So as a solution, we have to add a NAT gateway for our public subnet. So the NAT gateway is basically allow our resources in the private subnet to access internet and grab any updates. But anybody else outside internet cannot access our task using this NAT gateway. So that's how the NAT gateways are designed. So let's do that. I will go to my services and select VPCs and open it in a new tab. And then from the left sidebar, I will select NAT gateways. I don't have any NAT gateways created, so I'll create NAT gateway. Okay, now we have to specify a subnet where this NAT gateway should run. So always a NAT gateway should run in a public subnet with internet accessibility, because NAT gateway should be able to access internet on behalf of our private tasks. So it has to have internet accessibility. So in this case, I'm selecting my VPC public one because it has internet gateway attached. And then I have to allocate an elastic IP. So I will click create new IP button. It will create a new IP, EIP, and assign it to this. And then I click create a NAT gateway. Okay, so it's created. Now I can just click edit route table button, and then let me filter my VPC. I will select here my VPC. Then I will only see the route table associated with my VPC. So now I basically have to change my private route table, which is associated with my two private subnet. Now I can see the subnet association if I click on this button. There you go. Both my private subnets are attached to this private route table. I will go to route section. So at the moment, it only associate one route CIDR, that is routing locally. So I will click edit routes and I will add a new route 0.0.0.0/0. That means any IP address other than an IP address from this range, and that should be sent to the NAT gateway, not to the internet gateway, but to the NAT gateway onto this NAT gateway ID, and then I will save routes. Okay, so I have this new rule added in my route table. Now our task should be able to reach out to internet. So let's go to our ECS tab here, and we'll see if our services are now getting active. So at the moment, still I don't see any running tasks. So let me go to tasks here. So it's still in the pending state. Let's do a couple of refreshes and give it a couple of minutes. There you go. I got one task in the running state. That's a good sign. The other one should also be at running state in no time. Let me do another refresh. Alright guys, so both of my services are on the running status now. We have to do one other change. Now if you can remember, we have allocated a security group for this service. So we have to make sure that security group has an inbound rule from the security group attached to the Elastic Load Balancer. I think at the moment we have set up only the HTTP access from anywhere, but that's not going to be enough. So in order to update the security group inbound rule, I can simply click update here because I'm in the service hello world. So let's update this service. Click on that. So give it a second to load all these variables. So I will select next step without changing anything. And here under configuration, the network section, you will see the security group of that. So I will just open that security group in a new tab. Now this security group is attached to our service at the moment. Now I went ahead and added the security group ID of my load balancer to accept all TCP traffic as inbound rule. Now let me show you how to find the security group of our load balancer. You can open up a new tab. I will go to services and open EC2 in a new tab. And now let's go to load balancers section on the left side. Now I will expand this section a little bit and scroll it down a little bit again, and then under security section you should find the security group attached to this ALB. Now I will open this, so it is SG076. So let me open this. There we go. So this is the security group attached to that, and its name is my ALB security group as well. So I can check the inbound rules attached to this security group. You can see HTTP is allowed on port 80 from anywhere. So that's all fine because my ALB is accessible to anybody in internet. But now what I want to restrict is accessing to my private tasks, or rather the service that manage my tasks. So I only want this ALB to access my tasks in the service. So what I'm going to do is I will copy this security group ID and then go back to my service security group. It is this one, and I will click edit all rule and I will select all TCP, and then here I will paste that security group ID. So this is the security group ID of my ALB, and I will save the rules. So after that, I can go back to my load balancer. Here we go. And I will click listeners here. Then you can see there's a listener set up for HTTP port 80, and that will forward traffic to my ECS Hello World target group. So let me click on that. So all traffic coming from that port 80 will be forwarded to this target group. And there we have the target group. If I check the targets right now, and the targets are all healthy. And you can see the IP addresses 10.0.3.207 and this IP addresses where my two tasks are running on. So now everything is connected. Just to confirm everything is working fine, I will go to load balancer again and then I will copy the DNS name and then I will go to one of the browser window and hit enter. There we go. I have my hello world message printed out. So just to summarize the flow again, anybody in the internet can use the DN of my load balancer, and once the request is made to the load balancer, what happens is that request will be forwarded to a target group attached to that. So I will click on the target group, and in this target group, ECS will automatically register these two IP addresses that is attached to the two tasks managed by our service. So let me show you the service. So this is my ECS and I'm in my cluster and ECS has this Hello World service. So this Hello World service, let me click onto that. It has two desired task count managing. So always this service will make sure it's running two tasks. So if I come here and stop one of these tasks, I will click here and then click stop. Then my service will only have one task running. So let me show you here. You see there's only one running task, but the desired task is two. So what will the ECS scheduler does is it will spin up another task. I will go to task section. Probably we can see it provisioning a new task right now. So still one task. So let's do a couple of refresh. There we go. So it's provisioning a new task. So yet I can access my website that is in one of the tasks from the ALB DNS and I have a highly available system. So during last three parts we have built an architecture like this. Now I have my code in my laptop. There's a containerized express application. Then I will build that containerized application locally and then I will upload that built image to AWS ECR, the Elastic Container Registry. And afterwards, in our ECS or Elastic Container Service, which use AWS Fargate, we created a new task definition using the image that we pushed onto ECR, and then we associate that task definition with a ECS service which maintain number of tasks that we have defined in AWS Fargate. I think we have spin up two tasks in the service. So our ECS, which use Fargate, will always maintain two tasks or containers per se, and those containers will run my Express application. So anybody from internet, they will access that through an application load balancer. And once they make a request, it will reach out to the ALB or Elastic Load Balancer, and that application load balancer will route that traffic into those tasks in my ECS cluster using Fargate. And today we are going to automate this whole part. We are not going to manually push container images to ECR, but instead we are going to use AWS CodePipeline to build the image and push it to ECR, and then we will have another stage to deploy that task definition using those ECR images into AWS Fargate cluster or ECS cluster that use AWS Fargate. So let's get started. Now, before that, a quick word about the NAT gateway that we have spin up for our tasks in the private subnet to access internet and grab the Express NPM dependencies. So this is going to cost you money. So if you are following along, once you have done with that, just make sure you remove this NAT gateway. Otherwise, you will be charged. Now I'm here in my ALB endpoint. So this is my ALB DNS name. Now if I refresh it, so I just changed the message to Hello YouTube. So the task, the container that runs in AWS ECS will send me this message. I have updated one of the files in the CI/CD container repository in GitHub. I want you to take a sync. I have added this buildspec.yml file. So first, let's take a sync. You can easily do that by git pull. So it's already updated. Make sure that you have this buildspec.yml file. So this is the one that we are going to use in our AWS code pipeline in the build stage. Now, the first step is to link our GitHub repo with AWS code pipeline. So right now I have my GitHub repository which is not linked with any code pipeline. I will create a code pipeline first. So let me go to AWS Management Console and make sure you are in the region where your ECS cluster is. So my ECS cluster is in EUS East 1, North Virginia. So I'm going to create a code pipeline in the same region. So I will click code pipeline here, or you can search it here. So I don't have any code pipeline at the moment. So I'll click create pipeline, name it, let's say YouTube. And here you can either create a new service role or use existing service role. So I'll create a new service role and then I'll click next here. So this is the place where we are configuring the source code. So where are we getting the source code? It's basically from GitHub. So I will pick GitHub here and then you get this button connect to GitHub. Click on that. Then you might have to click accept and allow screens. I have already allowed those security questions. Afterwards, you will get this message. You have successfully configured action with the provider. Then if you click on repositories, you should see all the repositories in your GitHub. I will search for CI/CD. So this is my repository. So I will select this one. So if you are following along, you can easily take a fork into your GitHub repository and then link it with AWS code pipeline in code build stage like this. And the branch that I'm using is master branch. And then select GitHub webhooks. So every time you push a change to GitHub, this will be triggered. The code pipeline will be triggered. So source stage is now configured. Now we'll go to the build stage. So this is the place where we are going to use AWS code build. So pick code build and select the region US East 1 and then click create project. So it's going to open up a new window. You can maximize that. Here I can give a name to my code build project. I will just say build. And then I have to pick the environment that this code build should use. So here I can either use a manage image or custom image. You can specify a Docker image, but I'll use a manage image here. And the operating system that I'm going to use is Ubuntu. Pick this one. You can pick the runtime as standard. I think this comes along with Docker install if I'm not mistaken. And then the image, you can pick standard 1.0. If you are picking standard 2.0 in the code build spec file, you have to specifically mention the runtime. In standard 1.0, you don't have to. So just specify or select 1.0 here. And the image version, always use the latest. And then make sure you check this because it says enable this flag if you want to build Docker images. Because we are going to build the Docker image out of the code that we get from the source stage, check this. And then I can create a new service role or existing service role. You can give it a name. I will just rename this to YouTube, AWS Code Build YouTube role. And later on, we'll go to this role and provide the permission to pull images from ECR. So we have to provide the ECR power user policy, the manage policy. We'll do that afterwards. Additional configuration, you don't necessarily have to add anything. And here, you can either use a build spec file or you can insert the build command here. So this is the place we are going to make use of the build spec file that you might have checked out when pulling the latest code from GitHub. So I will open the build spec file. So this build spec file defines what are the steps that code build should execute. Now there are several stages: pre-build phase, build phase, and post-build phase. Now if you can remember, when we are pushing our Docker images to ECR from our local machine, first we had to log into ECR. So that is what happens at pre-build stage. So this is the same command that we use to log into ECR. So we are using AWS ECR get login. So after this, you will be successfully logged into ECR. And then at the build stage, first we need to build our Docker image and then we will tag our Docker image, and after that in the post stage we will push that built Docker image to ECR. So that is what happens in this line. Now let's replace these placeholders. So you build the Docker image using docker build-t. So this is the image name and this is the context. So the current context, you can find the Docker file here. So image name is this, so I will just copy this one and I replace the image name placeholder. Now we are going to tag it. So we are docker tag the image. Then we are tagging with our ECR URL. So where to find that? Let me open ECR in a new tab. So this is our repository. Click onto that and there we go. So this is our full image URL. So copy that one and come back here and replace it with this. So Docker tagging part is now complete. And after that, we need to push this tagged image to ECR. So how to do that? So it's basically we have to use Docker push. Again, the ECR URL, the same URL that we have copied. Then it will successfully push my image to ECR. But that much is not enough because the next step is deploying a task definition into our ECS cluster. So in order to do that, we have to provide some information to the next step. So that's what we are doing in this line. So we are basically creating a new JSON file and we call it image definitions.json, and this JSON file contains this content. So it basically has a name. So here we have to replace it with our task definition name. So I can find my task definition name if I quickly go to ECS. The cluster that we have used or configured in previous lectures was this one. So here I will go to task definition. So the task definition name is hello world, you see. So I will just copy this and come back here, and task definition name, I will paste it here. And then we have to provide the image URI for this task definition. So that is nothing but our ECR image URL. So I will just copy here and replace this placeholder here, and then output that JSON file into a file called image definitions.json. And then as artifacts, we will have our image definition open for our next stage to be used. So what is the next stage? The deploy stage. So I'll replace these values and I will copy this content, and let's go to our code pipeline here. And you can see we were here, using a build spec file or inserting the build command. Now I can do either way. For simplicity, I will insert the build command in line. So I will select this, switch to editor, and then clean all this code here and replace it with the copied code. And let's move on. Make sure you check this one, CloudWatch logs, so we can see any logs, and then I will click continue to code pipeline. So it says this is already existing because I created one of these earlier, so I just say build YouTube as my project name, and let's try again. Okay, it was successfully saved and it got me back to my code pipeline stage where I left off. So now it's filled the code build project name here. I can click next, and this is our next step, which is the deploy stage. So at this deploy stage, we are going to use ECS as our provider. So this is a very easy way of deploying services to ECS. So I'm using ECS deploy provider, and then I have to pick the region US East 1. The cluster that I'm going to deploy is my cluster. So this is the one we have created in previous lectures. And the service that I'm going to deploy into is hello world. And then I'm asked to enter the image definition file, the JSON file that we have outputted in the previous stage, which is image definition.json. At that, make sure you spelled it correctly, and then I will click next and review and click create pipeline. So it's created and it start pulling in the code from GitHub, but it's going to fail at this build stage because we haven't added the permission to our code build role. So what we can do here is I will go to code build. So you see it failed. Now if I click on the link here, I should see the command execution error. So this part it actually didn't run, getting access to AWS ECR because we don't have the necessary permission attached to that role. So let's do that. I will go to services and I will go to identity and access management, open it in a new tab, and here I will go to roles. The role I created is code build YouTube role. So this is the one I attached to my code build project. So I will click here. You can see I don't have any permission to communicate with ECR. So I'll do is I'll click attach policy, and then there should be a manage policy. If you search for EC2 container registry power user. So this should do. You don't have to give full access. Power user is enough. And then I will click attach policy. All right. So with that, my AWS Code Build project should be able to log into ECR. This error message will not show again. I will go to Code Pipeline and I will trigger a new release. So I go back to Code Pipeline here. The first one is failed. That's fine. Click onto that and I will click release change. Release. So it's going to go in progress mode, pulling in the source. Build stage started. We'll see if this is successful. I will click onto the code build project again and let's view the logs still in progress. And as you can see, the login is succeeded now. Log into ECR and our Docker image is also built. You see the steps are also executed. And finally, it has created this image definitions.json file. I think this should be fairly completed now. Yes, it succeeded. Okay, so the build stage is now complete. Let's go back to our code pipeline. Check the next stage, which is deploy stage. See, build state completed. Now it is deploying. So deploying to ECS now. So if I click on ECS, the link here should take me to my cluster. And as you can see, hello world 8. Earlier it was 7. Now the task definition number 8 has been created. Now let's look at that. See, hello world 8 has been created. Now if I go to the cluster again, you can see there's 4 tasks running at the moment. But the desired count is 2 tasks. So let's see what's happening there. So desired count is 2, but there are 4 tasks running. So I will go to tasks section. Then I will see all those 4 tasks. As you can see, there are 2 hello world 8 version tasks and there are 2 hello world 7 tasks. Now these were all tasks. So what ECS will do is it will remove these 2 tasks and will maintain the desired count to 2 with the latest tasks definitions. So that's going to take some time. So I'll pause the video a little bit. Okay, deployment is now complete. You can see it succeeded. I will go to my ALB now and then do a refresh. You can see it still show hello YouTube. That's all fine. So what we can do here is we'll do a change to the message. So I'll come here, go to app.js. So instead of hello YouTube, I'll type hello world with 2 exclamation marks. And then I'll come here and I will git add all the changes and git commit, change display name, then hit enter. Then I will push the image to origin master. So it's completed. You see the change display name 23 seconds ago. And now if I go to code pipeline, and I should see the code pipeline is in progress now. So as and when I commit the code, the webhook triggers and then it starts the code pipeline. There you go. So now it's running the build stage. So by the end of this code pipeline, I should see my message ideally. So I'll pause the video and check this. Okay, the code pipeline is now completed. So now let's go to our ALB DNS or the URL and let's refresh. So this is the moment that we've been waiting for. So I'll click refresh. There you go. Hello world. Perfect. So my code pipeline pulled the code from GitHub, then it built the Docker image, tagged it and push it to ECR, and at the deploy stage, it created a task definition and deployed a task from that definition to our service so that our load balancer can route traffic to those tasks or the containers. Hence, the newly created container showed me the new message, hello world. Alright guys, so this is what I want to show you. With this, let's conclude this last part. And I want to remind you again, once you are done with this, make sure you delete this NAT gateway. Otherwise, you will be charged. Okay, I will see you again in a new video. Thanks.